Looking at our review question from yesterday, we are trying to solve and graph our solution set. It is already in factored form, which is helpful because it makes it easier to find those zeros. So what makes the first factor 0? 2. And the second one? 7/2. 7/2 is the same as 3.5? Okay, so picturing on a number line, we have a 2, we have a 3.5, and we know that we are at 0 for both of those. Yes? Then what did we do? If we were solving it algebraically, what did we do? Okay, so we had to test a point, right, in each interval? Yes? Okay, so if we tested, say, a 1, if we put a 1 in here, do we end up with something that's positive or negative? Putting 1 in the first one, 2 minus 1 is 1, 1 squared is 1, timesing by 1 isn't going to do anything. In the second factor, 1 minus 3.5 would be negative 2.5. So we're going to get a negative number. Okay. Testing something between 2 and 3.5. 3. Okay. Plugging a 3 in. 2 minus 3 is negative 1, but then it's squared, so it becomes 1 again. 3 minus 3/2. Negative 1/2. So we're still at negative. And then testing something above 3.5, say the 4. What do we get if we put a 4 in here? Negative 2 squared becomes 4, so that's a positive piece. 4 minus 3.5 is positive. Yes, positive times positive. We're going to be in the positive section. So below 2, we were negative. Between 2 and 3.5, we were still negative. And beyond 3.5, we were positive. Yes? And the question asked, where are we what? What does less than 0 mean? Anything below 0. So we'd have to be a negative value. Yes? So this interval would work. And this one? Can we be at 2? What happens when we put a 2 in? We're at 0. Can we equal 0? No. So when we look at this, our solution is going to be between the 2 and the 3.5. All right, we want that part of it. Okay, and then what else do we want? Anything below the 2, but we can't be at the 2, right? So we have to use the rounded brackets going in both directions at 2 to show that we're getting really close to that 2, but we can't be there. In interval notation, we would say negative infinity to 2 and jump over 2 and go up to 3.5. Okay. Does that make sense? Graphically, we looked at the leading coefficient to help us figure out, and the degree to help us figure out the shape. So picture taking this 2 minus x and squaring it. Okay. When you FOIL that out, you'd end up with a positive x squared. Right? Negative x times negative x would be positive x squared times this x would give us a positive x cubed. If we have a positive x cubed as our first term, what does our graph look like? Starts low and twists to go high. Okay. And do you remember when we talked earlier in the chapter, this 0 at 2 had a multiplicity of 2? Do you remember what it does then? It bounces. So we are starting low. We're going to bounce off the 2, and then we're going to twist and go through the 3.5. Does that make sense? So does that match what we found algebraically? Yes? Okay. That was a polynomial inequality. Today we're focusing on rational inequalities. So we're going to have polynomials as numerators and denominators. We are still looking for those key points, but instead of just having zeros, we now have to worry about vertical asymptotes as well. Okay, so we're going to look at this first example. We have 3x plus 3 being divided by 2x plus 4. We want it to be greater than 0. So strictly positive, we can't be at 0. All right. We've given you a picture of it, but we are going to be solving these algebraically because for polynomials, we can predict the shape of the graph a little easier than we can for rational ones. All right. We had some kind of weird shapes over the last few days. So we are going to solve these algebraically instead of trying to figure out what the graph is going to look like. We have a vertical asymptote at what makes the denominator 0. What would make 2x plus 4 equals 0? Okay, and we have zeros at what makes the top 0? What makes 3x plus 3 equal to 0? -1? Yes? No? Okay, so if we were going to go through our algebraic process, we know that at -2 we have a vertical asymptote and at -1 we have a 0. Okay, now remember vertical asymptotes is a line that your graph's approaching, but it's never going to get there, correct? So that -2 is never going to be included in our answer. We can't actually be there. But it does break my graph up, so I have to look at each of the intervals. Okay, so we are going to look at each interval. We're going to test a point, and we're going to look at what kind of result we get. Is it positive or negative? Okay, so picture making a little table. First interval, we're going to look at from -infinity up to -2 in that chunk. Okay, so from -infinity to -2, that's our first interval that we're going to use. The next interval will be the chunk between -2 and -1. And the last interval will be everything beyond to the right of -1. Okay? So we have 3 intervals we're going to look at. And we're going to test a point in each one. So what's a good point to pick that would be to the left of -2? Could use -3. Okay? What's a good point to pick between -2 and -1? Okay, we could just use -1.5. That would work too. All right, anything between -2 and -1 will work. Something to the right of -1. 0 is an easy one. Okay. And again, we don't have to worry so much about what the actual y value is when we plug that x in, but we're just trying to figure out is it positive or negative. Okay, so we are going to plug in a -3 back into our function here. What happens for the numerator if we put a -3 in there? 3 times -3 would be -9, plus 3 would be -6. Okay. On the bottom, if we put a -3 in, 2 times -3, -6 plus 4, -2. So we had a -6 over on the top and a -2 on the bottom. Negative divided by negative is going to be positive. So we are going to get a positive result here. Okay. Go ahead and put in -1.5. What's 3 times 1.5? 3 times 1.5. What is it? 4.5? 1.5 plus 1.5 plus 1.5? 4.5. Okay. It was a -1.5. So 3 times -1.5 would be -4.5. We're adding 3. Is that going to be positive or negative? It's going to be negative. So our top is negative. Okay, on the bottom, what is 2 times negative 1.5? Negative 3 plus the 4 would give us a positive. So we had a negative on top, positive on the bottom. Negative divided by positive is negative. Okay. If we dump in a 0, what do we end up with? 3/4, so a positive answer. All right. And the question asked us, where are we strictly positive, right? Where are we strictly positive? So we are positive in this interval, and we are positive in this interval. So those would be my solution pieces, from negative infinity to negative 2. And then also we need the interval from negative 1 to infinity. Okay? And a graph of that solution would look like this. Okay? So a lot of the same steps that we had yesterday. It's just that we have a rational function, so it's not as easy to picture the graph and answer it that way. Okay? So we will be focusing on more of that algebraic technique. All right, so we have 3 that we're going to go through. The first step, we want to get a 0 on one end. All right, this is a little trickier than we had yesterday with just regular polynomials. All right, we need to get a 0 on one end. And the other side, we need to have it as a single rational expression. That means if we have pieces to move over, we need to get common denominators. We need to get it to be a single fraction. Okay? So the first step I'm going to do is I'm going to bring that 2 to the other side. Okay, now I left a little gap there because I do need to get a common denominator. What would I need to multiply by? An x plus 3? All right, so we are going to multiply in x plus 3 over x plus 3. So we're really multiplying by 1. We're just making it look like it has a common denominator. Numerator then, we have x plus 1. And if we distribute this, we get negative 2x minus 6. What does that numerator simplify into now? Negative x minus 5. All right. We are going to use that when we test our points. Okay? Questions about what we just did there? I subtracted the 2 over, and then I multiplied to get a common denominator. And I combined like terms. Okay with that step? All right. Next step, we're going to find any vertical asymptotes and any zeros. Vertical asymptotes are what makes the bottom equal to 0, the denominator. Zeros are what's going to make the numerator equal to 0. So based on this function that I came up with, where do I have a 0? I'm looking for where negative x minus 5 equals 0. Could add the x over. Okay, so x is being negative 5 would get me a 0. Vertical asymptotes, what makes the bottom equal to 0? In this case, we'd have one at negative 3. The zeros and the boundary point, or the vertical asymptotes, are your boundaries. Okay, that's what's going to split your graph up into the different intervals. Okay, we're going to create a table and test those intervals. All right, so in my table, my first interval will be everything to the left of negative 5, so from negative infinity to negative 5. My next interval will be the chunk between -5 and -3. And my third interval will be from -3 on to the right. Okay? All right, so what's a good test point to the left of -5? -6 we could use. Okay. What's a good test point between -5 and -3? -4. And a point between -3 and positive infinity. 0 is an easy one, right? Easy to plug zeros in. Okay. So going through, again, all I really care about is, do you get a positive or negative result? Okay. So if we put a -6 in, we're dumping those test points into that simplified version. Negative times -6 makes it a positive 6. 6 minus 5 is 1. So we have a positive on top. For the denominator, what's -6 plus 3? So we have a positive divided by a negative, which is going to end up being negative. Okay. We put a -4 in. Negative times -4 becomes positive 4. 4 minus 5 is negative. Top is negative. Denominator, -4 here plus 3. Still negative. What's a negative divided by a negative? Okay. Putting in 0. Numerator, we end up with -5. Denominator, we end up with a 3. Negative divided by positive is negative. Okay, now go back to the question here. We were being asked where we are 0 or positive, correct? Greater than or equal to 0. So intervals that work, we have this one, right? It made it positive for me. And we also need to worry about where we're 0, because we can equal 0, and we could equal 0 here. So we can be at 0 and anything in this interval, correct? So my solution, we want to put it in interval notation. My final answer would be everything from -5 up to -3. Do I include the -5? Yes. So squared off bracket, do I include the -3? What happened at -3? We had a vertical asymptote, right? We said we never include those. We can't ever touch the vertical asymptote. Okay? So that's my final interval notation. If we were asked to graph it, it would look just like the same thing on a number line. Do you see the similarities to what we did yesterday? The idea of testing a point, seeing if it's positive or negative. Okay, so the difference here is we have the rational function instead of a polynomial one. All right, we've got 2 more we're going to work through. First one is not equal to 0. So we have to get it that way. All right, we're going to bring the 1 to the other side. I'm going to subtract it over. And then what do I have to multiply by to get common denominators? Yeah. All right, so we end up with 2x minus an x and minus a 1, which simplifies into what? All right, x minus 1 over x plus 1. So what makes the top 0? Okay, so we have a 0 at 1. What makes the bottom 0? All right, so the key points that are going to break up my number line are -1 and +1. Yes? All right, at +1, we're 0. At -1, we're undefined, right? That's that vertical asymptote. Okay. So think about your intervals. We need an interval to the left of -1, so -infinity to -1. We have the interval from -1 to +1, and we have the interval from 1 to infinity. Okay, we're going to test a point in each section. Something to the left of -1, we could use -2. Something between -1 and +1, 0 would be easy. Something bigger than 1, we'll use a +2. Okay, so testing those points. If we dump them into our simplified function here, okay, putting a -2 in, what happens to the numerator? Is it positive or negative? It's negative. If we put a -2 in the denominator, it is negative. A negative divided by a negative is positive. Okay, dumping 0 in, we end up with -1 over +1. So negative. Plugging a 2 in, numerator becomes positive. Denominator becomes positive. A positive divided by a positive is positive. All right, so what sections did we want? We want to be greater than 0, right? Or equal to 0. So I can be right here. I can be equal to 0, or I can be something positive. And the section that gave us positives would be everything down here and everything up here. Yes? All right, so final solution. We can be from -infinity to -1. We can be from 1 to infinity. Do we include the 1? Yes. All right, so my graph would look like this. Okay. The last one that we're going to look at. What is it set equal to? All right, so we already have a 0 on one side. That means we can bypass all of the trying to get everything to one side, get common denominators and all that. We can go right to finding vertical asymptotes and zeros. Okay, I'm going to pause the recording. I want you guys to try this as a group. All right, so we already have it equal to, or in this case less than 0, but we have one side as a 0. All right, so we're going to look for our zeros. What makes the top 0? 7/4. Okay, vertical asymptote, we are looking at what makes the bottom 0, and that is 2. All right, so on a number line, we have 7/4 and we have 2. At 7/4 we are at 0, and at 2 we are undefined, right? That's that vertical asymptote. All right, so thinking about my chart. So my first interval would be from -infinity up to 7/4. As a decimal, what's 7/4? 1.75. So we need something to the left of 1.75. What did you use? 0. Okay. Next interval was the 7/4 up to 2. What number did you try in there? 1.9. And then we had an interval from 2 to infinity, and you tried 3. Okay, so what did you get if you dumped a 0 in? We got a negative, right? End up with -7/6. So we got a negative result there. What happened when we put in a 1.9? Came out positive. Okay. And if we put a 3 in, came out negative. All right, so what did they want us to figure out? Are we looking for being at 0? Are we looking for being positive or negative? What are they asking? If we have to be less than 0, it means we just want the places where we're negative. Yes? So we want this interval and this interval. Do we include any of the endpoints? No, because we couldn't equal 0, right? And we can't be in the undefined section. All right, so final solution would be from negative infinity to 7/4, and then jumping over and picking it back up in the 2 to infinity section. Okay. All right, questions on that process? Okay. All right, so homework today will be section 3.6b. We are on page 420, numbers 43, 46 to 48, 52 to 56, and 59. So you have 10 questions to do.